In this tutorial for the unsteady state wellbore simulator USWS with black oil PVT properties, we're going to show how to use a pump for artificial lift of an oil water well. We're going to run a case for an oil water well with declining reservoir pressure to find the reservoir pressure or time at which the well will stop flowing, and then to put a pump in to try to extend the production life of that well. So let's go to USWS data file builder, and I'm going to open up a file which I've built previously but has no pumps in it. It's a black oil PVT case, so it's got the standard pressure BO RSBG curves, and it has a bubble point of 3000 kPa. The trajectory of this well is a vertical riser with a long horizontal section, and it's about 428 meters deep. 428 meters deep. The well length was about 1500 meters. In pipe data, once I've discretized the pipe segments, I can show you the schematic of the well. So the pipe schematic of the well, if I maintain aspect ratio, this is a schematic of the well. So in this case here, I've got a liner, casing liner section that goes from 1 to 108. So 1 to 108. The build section is about 64 here, 108. I got a tubing pump, but no pump at this point. This is the tubing, and it goes up to 765. So the first pipe, the outer casing liner pipe, I've cemented it in this manner, and the perforations are from 69 to 108. So 69 to 108, we've got perforated segments. So the reservoir inflow occurs along the liner, and the flow comes in and accumulates until it goes to here, and it comes up the tubing, and some of it may come to stop outside here. This liner is not open to flow, it's only the tubing that's open to flow. So if I look at the tubing pump section, it's 1 to 65. The last segment is open to flow, and it is this diameter sequence. So this is the description of the oil well, and the reservoir pressure is producing from 769 to 108. The reservoir pressure 8000 kPa with oil water saturation. That's right, 30% water saturation. And we're dropping the reservoir pressure with time. This is a shortened time frame because we're not really running reservoir time, but running to see the effect of the reservoir pressure decline on the behavior of the wellbore. The saturation pressure is 3000 kPa, and the relative permeability data, table 1, with the endpoint of 0.2 for the water table. So this initial water saturation of 30% or 0.3, water will flow. So we get an oil and water flow in the well at declining reservoir pressures. We're going to run it until 4 days. We ran until 4 days, and since the well is about 428 meters, so 428 meters deep, it means that we would have about 4,000, around 4,000 something. That would be the pressure at which the well would stop flowing naturally. So we should see the well stop flowing naturally somewhere around this pressure range here. So if we were to run the case, so I'm going to go back to general data, and you can see I have stopped running 4 days. So the reservoir data goes up to 3.5. 4 days is my general data. So I'm going to close the file, and then if I run the file, it takes fairly quick to run. I just spend a quick minute running the file, start run, and it's going to run and go through time. So it's a fairly quick run. And when it's done, I will open up the results of the run. So I'm going to show the results of the run. So resuming the video after a couple of minutes, the run is finished, and show the results of the run. And select the liner tubing, sediment pressure, oil saturation, water saturation, gas saturation all times. And for each time, report the pipes and parameters and report that run. So 0 days, 3000. Next time. So next time. So I should also select the oil rate, the oil rate flowing, water rate, gas rate flowing to the sediment. And next time, so we have a oil rate, natural flowing oil rate of 229 meter cubes of oil, 190 for water, about 3.198 for E3M3 for gas. And you can see the pressure at which that in the pipe, in the tubing pump, the pressure is about 3000 kPa, where gas starts forming in the pipe. Before that, it's undersaturated as per the bubble, as per the PBT. And the fluids are rising. Fluids are coming in from along the horizontal section of the well and accumulating, increasing total flow until we get a total rate of 229.1. And then it flows out through the tubing pump pipe through here and up through here. But there's some accumulation of water and oil in the bill section of the outer pipe. And you can go through time, next time, and you see that this changes. So I can actually go through and pick every 0.5 days because I know that was my time, my output, my sequence of time when I changed my reservoir pressures. And so if I choose to display, say, 3 records, 4 records, 3 records at a time, you can see that if I move through time, my rates are decreasing. Let's do 2 records at a time. So 2.5 days, 3 days, 2.5 days is my rates, 3 days is my rates. I can also add my reservoir pressure, and my reservoir pressure is 5,500, 5,000. So at a reservoir pressure of 5,000, the oil rate goes to 0. This well stops flowing. So at 3.5 days, or when the reservoir pressure is going down to 5,000 kPa, the well stops flowing. And the last rate of the well is about 200 meter cubes per day. So we need to size the pump such that it delivers about 200 meter cubes per day, and have a head that would allow us to cross the pressure boundary from 5,000 to about 3,000 kPa, to near about 2,000 kPa, or 200 meters of head. So if I go back to the data file and place the pump in the data file, open the data file, we want to put a pump in the tubing pump section. If I would actually, I have this data set already created. I'll quickly show it to you. It's quicker this way. In the pipe data, I have at 3 days when the reservoir pressure dropped to 5,000 kPa, I've allocated a pump in the last segment. So I've reversed the segment numbering from 65 to 64 because this is my suction head. For a pump, the suction is from 65 delivering to 64, whereas if a pump is 65 to 65. So I put in a pump at 3 days that delivers from 65 to 64, a pump curve number of 1. In the pump curve number 1, I do have a table range of 100 to 500 meter cubes per day with a head sequence 50 to 400. And these numbers are not used in the program at this time. So for this given pump head curve, we expect our rates to be around 200 meter cubes per day from our flowing well, and we would see a reduction of pressure across the pump segment of about 300 of 3,000 kPa. So when we run this case, and the case has been run already, I'll open the results of that case. Get the last used report selection. If I go to select the time, which is about 3 days, and now we introduce a pump at 3.5 days. That's 3.5 days. So I use 2 records. Go back previous 3 days, 3.5 days. This is the rate at 3 days, and previously at 3.5 days, the well stopped flowing, but now is still flowing at 3.5 days with the pump. And we can see that the pump segment, which is the last segment of the tubing pump pipe, we can see there's the increase in pressure of about 2,000 kPa to deliver about 300 meter cubes of liquid. 300 meter cubes. And again, you can see the gas only appears in the pipe at a bubble point pressure of about 3,000 kPa. And if we look at the next time, 4 days, even 4 days, when our reservoir pressure has dropped to 4,500 kPa, the pump is still producing fluid, so we can extend the life of the reservoir to 4,500 to 4,000 to 3,000 depending on our head curve, and we'll be able to deliver rates of fluids even for a longer period of time. If I display the well schematic for the water saturation, display the well schematic for the water saturation, you can see that this water accumulating in the annulus between the tubing pump and the casing liner. Very interesting. Thank you for your attention.